Okay, so let's look at now the second lecture for lab. That is going to be, again, more GPIO ports. It's also going to concern the LCD that is on board to our discovery board, and the external interfacing is going to be important for the first time. So we're actually going to hook the board up to something else. Okay, so first off, what do I mean by an external device? Well, let's take a simple device. We're just going to try to light up a 7-segment display. Now, the thing that you can think of with a 7-segment display, you can see here clearly this is what I'm talking about. The 7-segment display is like one of the clock digits that you're used to seeing from an old clock radio or something like that from forever ago. Okay, and why is it called a 7-segment display? Well, here is one segment, another segment, another segment, another segment, another segment, another segment, and a final segment. So you can see I've circled 7 segments. Then if you count the decimal point, that will give you a total of 8 segments. So the 7-segment display is basically consisting of just diodes. And so how is this being controlled? Well, in this case, what you see is you see 2 ports, or 2 pins are controlling what we often call the anode of the diodes, and notice that all of the anodes in this one are connected together. So this is sort of called the common anode configuration, because they all have this, all of the anodes of each of the diodes are connected together and they're common, and it looks like you can access that with pin 3 and pin 8 of the 7-segment display. So here would be pin 3, here would be pin 8. So basically it's showing that those 2 pins are sort of tied together. And then we have the cathode of the diode down here, and those diodes each have a cathode that is not connected, and each segment is being displayed as 1 pin on this particular chip. So A has a pin, and that matches with A. So let's just make sure we see what they're saying. So that is pin 7. Pin 1, which is right here, is the E segment, and that's that one. Okay, so what our goal for the lab is going to be is actually to be able to turn on the 7-segment display and get it to light up digits how we want it to light up digits. So let's just make sure we understand what I'm saying there. Okay, let's go back and look at our 7-segment display. Well, if we have our 7-segment display, then we need a couple of things. Let's say we want to put the number 4 to be lit on the 7-segment display. Well, that means we need segment F, segment G, segment B, and segment C. So we have to find a way to light B, C, F, and G. And if we do that, we'll light 4. Now, how is it we're going to particularly do this? Well, we have the ability to easily, I guess you would say, use the output ports of our GPIO pins to do this. And we can set it up so that we output either a 1 or a 0, which will be a certain voltage to basically get that light to turn on. Now let's think about this as we do it. Okay, if we want to light it up, how do you light an LED? Basically, what happens with an LED is if you put a positive voltage across the anode with respect to the cathode, then you're essentially going to turn on and it's going to light up. You have to exceed a certain voltage for that to happen. So like if I put it at 0 volts, that LED is not going to turn on. As I increase the voltage, I'll finally get to a spot where I see that the LED emits some brightness that I can actually easily tell that it's lit. And from that point forward, what could change is maybe how bright it is, but in general, once it's on, and any increase in the positive voltage from here to here is going to not really, change it. Obviously, you could get too high a voltage and maybe you would break the diode, but in general, what we think of is we're going to put this positive voltage across the diode. So if we can somehow come here and put a positive voltage on the diode here with respect to the negative voltage here, then we'll be okay. That's how we'll light that one. But notice that when we do that, we don't want to make, let's say we want to light 4, we would want to put a positive voltage there, and we would want to have the ability to make sure that, let's see, we turn B, C, F, and G on, so we want to basically be able to turn B on, C on, F, and G on, but somehow we don't want A, D, and E on, and of course not the decimal point. Now, one of the things that I like to point out about this particular slide is these chips that we have right here can be either common anode or common cathode. Common cathode basically switches and has all the has these diodes all facing up basically, and the cathode is common to pins 3 and 8, and the anodes are all tied down here. That's actually a rather simple one, a simpler case, I think, to understand how it's going to be hooked up. But in any case, that's just this drawing for this particular one right here. Obviously, you can sort of guess if you do it one way, you're going to get the light lit, and if you flip the diode, then you're going to get the light sort of lit for the opposite direction you'd expect, as long as you do things the right way. So you can come here, and what you can do is you can put a hookup on the board so that you can get this 7 segments display to light. Now we'll talk about that more as we get the pins for this to go, but let's just say we can somehow get VCC from the board, and let's just think of what we could do if we could get VCC to the board, and then we could go, let's just do this path right here because we said we wanted to light that segment. We can light this segment. Now we'll put a resistor on here, and what's the resistor for? Well, the resistor is there just to not have infinite current, and when we short the diode to crash out how much can be supplied from this VCC source. So anyways, we put the resistor there to limit current, and then we can either have down here at pin 5, we can have it tied itself to a high, which would be basically VCC in the first place right here. So if we have VCC and VCC down here, then there's no voltage drop net across that diode, and so this would be 0, the diode can't turn on, the current in the path would be 0, and it'd be done. The alternate though is, so when we put a high on pin B here, then we would get, nothing out. When we put a low, which basically means essentially like grounding it, then we have VCC and ground there. We can have a positive voltage across this diode, current can flow, the light will light up. So if we wanted to light up 4, what we could basically do is we could have B, C, F, and G. We could have ground, oops. Ground, what is this thing doing? And ground, and then we could tie E to VCC. Well, maybe I just tie all those pins to VCC, and then we would have a high on the output. So if we can, in this case, if we have the common cathode set up, then, the common anode set up, we can use this is basically our output ports, tie this to VCC, and that's the way we'll be able to get the light to light up in the way we want it to do. Now, if you didn't know which kind of device that you have right here, what do you need to do? Well, just be smart. Put this on your board. If we didn't know if it was common anode or common cathode, put this on your board. Just try to run to pin, okay, we know E is right here. We can run a pin, we can run a voltage source VCC, run it through a resistor, run it through that, and then, not that, sorry, my bad. Run it through the common terminal, and then tie this to ground, and see if we just do that simple little setup, did E light up? So did this segment light up right here? If it didn't, then do we have the opposite, which would be, the opposite would be E would have this, and pins 3 and 8 would be that way. Okay, so again, we could put, if we were trying to check out that, we could look at this particular thing. The thing that's tied to the common, we'd want to go to ground in that case. E would be where we'd want to put the positive voltage, so we'd put VCC. We'd put our resistor just to protect ourselves, and then we'd go to E. And then if this circuit, when we hooked it up, that segment lit up, we know that our particular chip was common cathode. Okay, so that gives us a little information. I know that's a whole lot for one particular slide, but it gives us an idea of everything that we sort of need to know as we move forward and we want to talk about that particular setup. Okay, let me say one other thing. I sort of bypassed this part, which was important for the overall understanding of what's coming next. It says, how many pins do we need to control this? Well, obviously, you can see this is the layout right here. And it looks like when you have this particular setup, if you think of just the standard things, it looks like for each one of the segments plus the decimal point, we need a way to display that. So there needs to be at least 8 for those. And then, of course, you might say, okay, well, maybe you need 9 because you need that common terminal because somehow ground has got to be attached. So in any case, let's think about that, and that's what this says. The internal driver, it says, for our 7-segment display is basically done with just 7 pins. Now, what it's talking about is just the A, B, C, D, E, and F. That's all this is trying to say right here, so A through F. Not talking about ground or anything like that. It's software-based, and what that means is, okay, everything, if we wanted to do this for an internal driver between our discovery board and the 7-segment chip, it's all got to be done through software. And whatever code we put there determines the state of each pin. So again, when we want to put out a 4, we have to highlight F, G, B, and C. Those whatever pins are tied to those ports need to either have the VCC or have the 0, depending on if I have common anode or common cathode. Then that connection has to be made from the port of the discovery board to the chip. And so obviously the more 7-segment displays that you have, like for example, if you think of a clock radio, well, you need a digit for the hour, a digit for the minutes, a digit for the tens of the hours, and a digit for tens of the minutes. So you need 4 digits, plus obviously you need something for the colon, and so forth. So you need a lot of pins to be able to control all of that, which gets rather expensive because creating external pins is rather tough. So we could do it rather than using an internal driver, we could use an external driver. And so this basically has a different kind of internal face. It's hardware based. And what do they mean about the one we're going to use for this? Well, we really, I guess I should say, have two. We're going to have the LCD on the board itself, but we're also going to have a encoder that will, not an encoder, I guess I should say, a decoder that takes 4 pins that would go to 16 pins. If we, 4 bits could decode into 16 binary numbers. And so each code could display the actual data of the binary coded decimal that we're sort of looking at. It's obviously less pins and it's less software, but there has to be more hardware when you do that. So it's sort of like a trade-off, but obviously where this could go is you would expect, because of less pins, that's cheaper. So again, a little bit about the display mechanisms and what would happen for the coding. It says, okay, we have to figure out how to take the data to be displayed. We're going to have to interpret the data, decide which segments should be activated, and set pins on our output ports to high or low depending on what we want to have displayed. On the other hand, if we use this decoder, we're just going to send the data directly to the controlling hardware and be done with it. Hey, that's a little bit nicer. And it's also sort of similar if we use the LCD. So here is like the 7-segment display hookup if we're going to use a decoder. And so notice in this particular diagram, all we would expect to use are these, right? Because these aren't really decimal numbers right here, but because it's a 4-bit input, well, it will decode to 16 bits output, so, or a 16 digit number on the output. I still didn't say that right. A number that can represent up to 16 numbers on the output. So we have these that could be lit up, but they're not really important for us since we are just trying to display a number. So you can see that with this particular one we have A through G, the outputs of the 7-segment display, and now notice it counts it here for this decoder. This is A, B, C, D, E, F, G. Is that the same as our actual chip? Yes, A, B, C, D, E, F, G. It is. Of course, you can imagine that's sort of a standard that's been done to make sure it's consistent. So these lines here will go to the 7-segment display that we already talked about, and all the, so those will have to be wired just like you wired them from your output ports to that 7-segment display. But then what you'll have to use as your outputs from your board now will be going to these capital A, B, C, D ports. And you can see also here's VCC and ground. But you'll be wiring the ABCD, and you can see that if you output a decimal 0 as you count through this hex, basically 4 bit number, you can count through 0 through 15 to display these different digits. The one thing you can see here is this is negative active logic, so that common cathode sort of setup is sort of what would be nice to use right here, because when it's a 0, that means it's going to turn on A, or it's expecting, and that's sort of what we talked about right here. When we have a 0 here on, say for example this, and VCC up there, that's going to turn that particular segment on. I believe I actually said, I constantly get this confused because I'm talking about them both all the time, but that's the case that we have right here. And so when this is a 0 and we tie this to VCC, that will be on. And so that's a negative active logic. And this is actually the common anode right here that is displayed. Okay, so now let's just talk about what else we could do with a 7-segment display, and how might we also try to minimize the number of pins. And this talks about static versus multiplex. So this should immediately make you think of a multiplexed line, like a multiplexer. And what's going on here is, again, we're trying to find a way to reduce the number of pins. Okay, so static drive is what we talked about sort of at first, and it says here, this is a diagram from the book. And I'm not really going to go in detail too much here because all of the setup for this is going to be done. And then, when I say that, I mean all of the setup in your lab documentation and template, it's going to be done there, and you're just going to have to modify some of it. Not anything crazy, but just a little bit. But chapter 17 discusses the LCD way more thoroughly than we need to at this particular point. Actually, we never have to use the LCD that advanced, but at least right now all we're doing is sort of going to use it to display the number, and also, you know, just to give us an alternative of the 7-segment display that you're going to hook up. So anyways, what you see here says static driving duty ratio equals 1. It says there's only one common terminal in static driving. When a segment line has the same voltage waveform as the waveform of COM, this segment is turned on, otherwise the line is turned off. Okay, so basically what this is a way to use a clock, and if you know, either if you have a clock signal, you have a segment on the entire time of the, you know, the clock pulse, or it's off the entire time. Okay, if you change the duty cycle, what you can do is you can get it to have the same number of COM ports, but then you can switch which way things are turned on. And you can see here, for example, we have COM 0 and COM 1, so we have two common ports. And this gives us a way, it looks like, okay, now something sort of interesting. I can find a way to, if I tie the two commons there, it looks like I can find a way to maybe get rid of some of the pins that I need. So anyways, that's sort of the idea. But the difference will be then, like, one particular segment can be on for half of the overall clock pulse. So you've seen this before. I don't know if you've ever like taken video of a clock radio or whatever, and you sort of see it sort of flickering. Well, that's because of the multiplex drive. Anyways, you can have more common ports, and then that's going to make the, you know, the way the clock pulse is done, it will, you know, maybe have the particular segment on from 1/2 to 1/4 the amount of time to 1/8 or whatever. But each time you start to add more common ports, you can start to change the number of pins that you need. This is, you know, talking about a multiplex waveform, and it's talking about how it will go with the two separate segments and particular biasing, and when the light will turn on and off. And what it's trying to show here is like, okay, what happens? You're not going to turn the lights on unless you get, you know, something at a voltage V. Here, when it's lower than V, like even if it's V over 2, the light would not be lit in that particular case. But we're going to talk about this in much greater detail. I don't really want to do it now, except to say, okay, we can do that. Again, so here's talking about this one. It's showing you, okay, here the light would be visible because of that. Here, for the other one, it never gets above V over 2, so it's never visible. So that's what it's trying to say. This one is visible, this one's not visible. Again, we'll do this in more detail, but it'd take several minutes to go through all this as we try to do it. So one of the things to take away sort of importantly is, okay, let's just look at the overall internal LCD driver and why we're going through this multiplex approach. Well, it has 1, 2, 3, 4, 5, 6 digits. In addition to the standard 7-segment, you see that we have like these HJK extra segments that can display within a segment. In addition, we have colons, we have decimal points, and then we have these bars over here. So we have a lot of things that can be lit. And so one of the things that is going on here is it's basically saying, okay, how would you want to display, for example, as an A? Well, it says to encode an A, you need FE00 right there. And that's what would have to get sent to the display. And so what it's trying to show you here is, okay, where's that F coming from in this particular case? Well, if we're doing A, we know we need segment F, A, B, G, M, C, E. Okay, so this is the set of bits that we would need to set for this particular digit. So does G need to be lit? And wherever we want the segment lit, we're going to put a 1 there. So 1 needs to be, G needs to be lit, B needs to be lit. So that's a 1. M, yes, it needs to be lit, 1. E, yes, it needs to be lit, 1. So this hex number is F. Okay, so now we've seen how to get the first one. Then what about F? Okay, yes, it's lit, so 1. A, yes, it's lit, so 1. C, yes, it's lit, so 1. D, that's the first one we've gotten to. It's not lit, so 0. So this is going to be hex digit E. Well, since we've basically gotten all of the others, we did, we know we needed to light 1, 2, 3, 4, 5, 6, 7 segments. All the other segments don't need to be lit, so that's why these are zeros. I could go through them in painstaking detail like I did these, but that's how we would encode that. So this is somehow got to get there for the specific digit. Like, was it that digit? Was it that digit? Was it that digit? So forth. Because we've got 6 digits we could light. You should be able to follow this for digit 2. Make sure you can figure it out. And as long as you sort of have this down, that can tell you everything you need to know about what's going on with this next particular setup in the lab. Okay. I already talked about that a little bit. So here's the sort of the connections. You can see it's talking about this. What happens for our discovery board is that it is still an external connection. It's what it means by this is it's a connection from the Cortex microcontroller to the display. And what pins are connected? Well, here they all are. You can see port A1, port A2, blah, 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 all the way down here through port C11. That tells us about the different digits, and that corresponds to what's happening in LCD RAM 0 through 2. In addition, you can see that these different, like the different comms, there's 4s common ports. They're on port B9, port A10, port A9, port A8. And then you see, like, okay, what do they mean about, for example, let's just say 2C. They mean by 2C this second digit C. So the 1 through 6 is telling you about the different digits of your overall LCD, and then the letter is talking about the specific segment on the particular thing. Okay, so anyways, let's see, was there something else I wanted to say about that? I can't think of it. Oh, yes. Okay, so here's the LCD RAM sort of listed out in a nicer way, and it shows you, you know, how the particular setups can go in there. And so if we look at this and we think about this number, we can come back and see what does that mean we're putting in there. Okay, we're putting in 0, 0, 0, 0. So let's make it simple for ourselves. That's this. Then 0, 0, 0, 0. Okay, that's that one. 0, 0, 0, 0. So that's that one. C. Okay, C is the number 12. So that would be 1, 1, 0, 0. So we put that there. And now you see they're showing the ones there, right? But that's just to sort of give you an idea of what's going on, where they're coming up with this particular figure from. And then 3 is easy. That's 0, 0, 1, 1. So you see the ones there. And then the rest are zeros. So all of these are zeros. So they're telling you where they're putting things in this particular setup. So for LCD RAM 2, they're putting in zeros there, zeros there, zeros there. Then they're putting 4, so that's 0, 1, 0, 0, and then 2, which is 1, 0, and then zeros all the way through there. So what they're trying to point out to you is they're putting in 6B, 6G, 6M, and 6E. So B, G, M, E. B, G, M, and E. So those are lit. And then A, F, C, and D. A, F, C, and D. So what's being lit there is an 8 in that segment. So nothing real fancy. It's just a little bit more fancy than our simple 7-segment display. So if you can figure out how that works, then you know what needs to be put in your LCD RAM to display it. Not a big deal. But all of these connections are done on the board. They're done from the microcontroller on the board into the LCD. You don't have to do that, but your ports have to be set up differently. Okay, so this talks a little bit about that, and again, I think it's over what we need to really understand at this point, but what it's trying to tell you is, okay, software has to write the frame to the LCD RAM, it's going to lock it, then it's going to copy the RAM to the display, and because it does that, the LCD will display it, and then it can unlock the RAM and then go back up here and repeat for what it wants to write again. So this just sort of gives an overall view of what has to be done for the LCD initialization. Okay, we got to say disable the clock protection. That's a lot of the same thing that we've done before. It says how to do this. We have to write to that register. We have to enable this particular clock, and then we have to use that clock as the clock source for the LCD. Then we have to enable the LCD clock. So this is the same type of thing that we talked about at the beginning of the GPIO port lab, just enabling all this to get the LCD sort of started. Then we have to enable the ports on the microcontroller. Each one of those ports are set as alternate function, which is AF. We talked about that. So you can see all of these ports A, B, and C, which remember, here's these ports, all of them have to be set as alternate function, and they'll be set as alternate function. You can see alternate functions on the GPIO ports are 1, 1 for the for that setup, and then you can go through this configuration process, and you can see there it's setting the bias, the duty, all of that sort of stuff. All of this is done basically in the code for you. You're not having to do that. You're just having to change what number gets displayed. So, and it has sort of, I won't say highlighted, because obviously we're not doing highlights in the code anywhere, but you'll see where in the code, if you look at the at the particular code segment, what you'll need to modify. So here's just that clock initialization. Again, you'll see it in your code. You don't have to fool with it. It's done. It works. That's just getting it all set up for you. Here's the setup of the GPIO ports. And so this is doing all the same type of stuff that we talked about before. There you can see the alternate function setup that we talked about right here. And then, let's see, what else do we have? We're just setting up the GPIO ports like we would want, and so forth. Again, all that is done for you. And then this is just sort of going through the display process and what you need to do. Now, you're not going to have to do any of this here either. You're just going to have to change like the digits that get displayed. Okay. Remember, this is actually left over from the previous one where we were wanting to put in configuring the motor register for port E8, that LED, to configure it as an output. We did this before, so we're putting a 0, 1 there to configure it for the output. And then we did this exact kind of configuration before. What we did is we ANDed everything with 1s, except for this bit right here, because we wanted it to be a 0. And then we ORed it with having the 1 there, just in case it wasn't a 1 from that one. So our process to get a 0, 1 in here is done with this. And remember, we could have done it with this, but we actually did it with this mask, and then we complemented it. That's what we talked about doing before. So then we talked about the bit set and reset function, so we did that before last week, so I don't really have to go over that again. But remember, our goal first is we're trying to hook up this 7-segment display. So I think I've gone over that in enough detail. And so what we're trying to do is we're trying to go from this, and we can set it up as having something like VCC here, and then having each one of our output pins, we have an array that has resistors tied to it. And then you can tie that to your output pins, and if your output pins are high, then we're not going to be lit. If our outputs are low, it will be lit. So we're sort of doing that negative active logic by default when we do it this way. Now, what we haven't said is where we're going to hook it up on the board. Okay, we have to have pins for the board to hook up to that 7-segment. So this is just showing on our board we have pins that are along here and pins that are along here that you can see that you can attach to. So where you're going to attach is you can attach here for the 3.3 volts. You can attach here for the ground. You can attach here. It's suggesting port E8 and those right there to give us the 7 pins. Now, this is just trying to show you that we do have, it says we do have a somewhat random assortment of pins available on the board to use. We need to know some of these pins are shared with other things, like, as we know, the LEDs and the push buttons and all that sort of stuff are shared with other things. But we can use these ports, so all of these as outputs, and we can use those in our board to connect to that 7-segment display. So you'll have a breadboard just like you had last week. This whole discovery board is sort of placed in the breadboard where you have these PE8, these pins, as well as your ground and 3.3 volt. You'll need to put those in there, and you will have to hook things up based on those particular spots. So obviously you could have this be A, B, C, D, E, F, G, right? Doesn't have to be that way. You could do it some other way, but that's probably the most likely way you want to do things. And so again, I think the way you need to sort of get ready for the lab is look at your template that's in Lab 2 and sort of look at things. Think about how you would want to write out the code to set the pins low, to turn them on, set them high to turn them off. And it says, assuming that LED display is negative active, that's what I talked about. Write out what you would send to the output data register in order to display the numbers 0 through 9. So what that means is, okay, how would you display number 0? You need to do the segments that will light up those, and so forth. So basically, what combination of A, B, C, and D, E, F, and G will you need to write out a 0? Then what combination will you need to write out a 1? Then what combination will you need to write out a 2? And so forth. And so each time you want to write out a different number on your 7-segment display, you have to change the output of the ODR register to do it. Now, you have, since these are not all that difficult to do because they're all in 8, you only have to change the output data register for port E. Obviously, you have multiple ports you can do, but you're going to just need to do it for port E if you use those pins that I suggested. So that's what you have to do. And then you can use the bit set and reset functions to easily set those to 1s and 0s. Again, I think it's a good idea in your lab just to make sure you understand the appropriate hookup. Just try to use the 3.3 volt and the ground in your resistor array to actually do what you need to. Set up a single LED light to turn on. Then you will know how you want to arrange it in the code to make sure everything works. So this is what you're trying to do. Okay, and this is really doing more than I would expect you to possibly do this week, but it's giving you an idea. I hope everybody will at least be able to get through part 1 and part 2. And then hopefully, if you can, get to part 3. Okay, so what part 1 is doing exactly what I said, using port E and your 7-segment display, connect them, and then use it to display the number 5, and then you can show this to Jitendra. Then the next thing, it says turn on port A for the up and down buttons. So then it says program the board to display a number. So you pick it, I don't care. But then get a display 5 if you want to do that again. And then if you press the up button on the joystick, which is controlled by port A, so and again it has to be configured it appropriately. But if you press up, it'll count from 5 to 6, 6 to 7, 7 to 8, each consecutive push. If you press down, let's say it started at 5, you press down, it'll count to 4, count to 3. You can assume that you're not going to have to get lower than 0 and higher than 9 or anything like that. It doesn't have to be that complicated, but I do want, you need to make sure that if you say, start at 5, press up, it'll count to 6, press up, it'll count to 7, press up, it'll count to 8, press down, it'll count down to then 7, not back to 4. So make sure you do that right, and that's what you have here. So that's just sort of not really doing much different than what you had on your code before. And then the last thing it says is use the encoder, the BCD encoder chip, to control a 7-segment display. So again, now you're only going to need 4 pins to come from port E to control that capital A, capital B, capital C, capital D input from your or those 4-pin input on your BCD. But then you need to use the small a through G on the decoder to output to your 7-segment display. Okay, so here's the array that we've got. You'll see those in the lab. They're over there, I think behind the big lab shelving system. And then the pin connections are here. This is a little bit bigger connection, but for the alternate decoder, notice you're going to have to put, notice here's what tells you about pin 1, the 4 inputs that you have to put for your controller to count up are B, C, A, and D. So notice that's the A, B, C, D when you go through it. And then the outputs that are connected to your 7-segment display are those right there. So obviously you need to realize that, like pin A needs to go can't remember now where it was. Way back at the beginning. Pin A was pin 7. Oh, here it is again. Pin A was pin 7. So pin A here, which is pin 15 on the decoder chip, has to be tied to pin 7 there. So again, what this is trying to do is, this is the interfacing part that it's talking about. And so it's trying to get you to understand what you would need to look at if you're trying to hook up one chip to another chip, and how you need to go about and think about that, and then what code you may need to do to hook that up. Okay, so that's it for this. Notice that you didn't even have to use the LCD display on the board, but we will get to where we're using that in the following week. And so if you don't get through this third part, which I think last year everybody pretty much did get through the third part when we did this lab, but we sort of did this lab a week later than we are trying to do it this year. So anyways, I think we've covered everything, but you may, have a little trouble with part 1 and part 2. But hopefully I've given you enough hours with the 2.5 each that you will be in good shape. So 2 to 4:30 for section, for the people that were in the first section for lab, and then 4:30 to 7 for the people that are in the second section. And don't hesitate to ask Jatendra if you need help, but obviously also try to think about this and do it yourself. But look at the code in the template and make sure you look at it carefully so you can sort of get an idea of what you need to do as you're going through this. Okay, that's the end of the discussion for Lab 2.